Hello and welcome to my yet another tutorial on outlier detection methods. Previously, I have uploaded uh, the tutorial on other popular outlier detection methods like ShopNet method, Dixon-Thompson method, Rosner's method. Today I will discuss about log Pearson type 3 outlier detection method. This method was recommended in the Bulletin 17B in the year of 1982. So let us move ahead. And if you like this tutorial, kindly share and subscribe to this YouTube channel. And also try to subscribe to my newsletter, hydrogeek.substack.com. Before we begin discussing about this new method of outlier detection, kindly note this point. This method will help to identify both high and low outliers. That means if there is a data set, then it can identify outliers from both the sides. By side, I mean if you arrange the data set in descending order, that means from highest value or largest value to the smallest value, then both largest and smallest value can be a outlier. Now, some of the methods of outlier detection can identify only one side of the outlier. That is, either it can identify the higher side, that is the largest value side, or it can identify the outlier at the lower side, that means the smallest outlier side. But this method can identify both high and low outlier. By high they mean largest, by low they mean smallest. And this method can only be used for a longer data set. It is not meant for a data set which is small. Anything more than 10 is suitable for application of this method, right? And as I have earlier previously said, that this method was recommended in the Bulletin 17B in the year of 1982, and this bulletin was published by the Interagency Advisory Committee of Water Data. And this method presents the criteria of detecting outlier in a significance level of 10%. Okay, not 5% or 2.5%, 10% significant, 10% significance level, it can detect the outlier, right? Now, what is the criteria? That is how it detects the outlier, that I will discuss later on, but there is some criteria that you must remember. If the station skew, that means the skewness of the data, we can all find out the skew of a data set by using the skewness formula. The skew of logarithms of the data, that means the first step when you get the data set for detecting outlier, you have to find the log of each of the data. Okay, and when you find the logarithms of the data, you find the skew. Now, after you find the skewness, check that whether that skewness is more than 0.4. If it is more than 0.4, then check the high outlier first. If it is less than minus 0.4, the skewness, then check the low outlier first. And if the skew is plus minus 0.4, you can check both high and low outlier. okay, before you can detect the outlier. Okay, so what I say is anything, if the skew is more than 0.4, check high outlier first, then low outlier. If the skewness is less than minus 0.4, then check the low outlier first, then the high outlier. And if the skewness is plus minus 0.4, both high and low outlier can be tested. Now, how to determine or identify the high and low outliers? The formula for detecting high outlier is Y. That means, here each of the data set. Suppose you have a data set of discharges, river discharge. The first step of this method will be to find the logarithm of the data set. Find the log of each of the data, right? After then you use this formula. Now in the previous slide I said if the skewness is more than 0.4, then try to check the high outlier. So what is the formula for that? Formula for that is Y subscript L, that indicates the log of either low or high outlier, equals to Y mean. This is the mean of the log of the sample data set, not the data set. It is the mean of the log of the sample data set. First log it, then find the mean of it, plus K subscript n. This K subscript n is known as critical deviate, and you can find the value of K subscript n from a table which shows the critical deviate against total number of data in a data set. That means if you have 10 number of data in that data set, then there will be a specific value of K. If you have 14 samples in your data set, then there will be a different K. So on. Now what is S subscript Y? It is a standard deviation of log of the sample data set. Always remember everything here is with log. Don't do anything directly on the data. First convert it into log, then you find mean, then you find standard deviation, find the value of K from the table of Ks that is available in the internet or any book of statistics, and you find the value of K as per the number of samples in your data set, right? Once you found it, put it into this equation. For high outlier, you see mean of Y plus K multiplied by standard deviation of Y, right? So that will give you a value that is high outlier. But to find the high outlier, you have to find the inverse of that value, correct? And if any value is found to be more than that value, then you have to censure or delete all those values that are more than this value, including that value, or rather I would say including this value. And if your data set totally falls under this value, then no need to delete any data. Another thing you must also do, for longer data, multiple peak events are there, right? Multiple extreme events you can find in one single data set of suppose daily rainfall data of 1 year. You can find many peak values in it because it is a longer data, right? So once you point out that this is the discharge which indicates the highest outlier, try to compare that value with the historical data of that data set. Suppose you are doing outlier detection for 1 year data and you find a one peak value, the highest value with the formula of high outlier, then try to compare that high outlier data with the historical data. That means the previous year's rainfall or previous 10 years rainfall. If you see there are data which are more than that, this one, then this data may not be a highest outlier. It may be a peak event. So you include this data and again recalculate the or reapply the formula. Okay, and in case of low outlier, right, and what I say, if the skewness of the data is less than minus 0.4, you have to calculate the lowest outlier first. So lowest outlier can be found out by the same formula. You see, just the plus sign has to be replaced by the minus sign. So for low outlier detection, minus; for high outlier detection, plus. Every other variable is same. Y mean of the logarithm of the sample data. Sy is the standard deviation of the log of the sample data. K is the critical deviate. Everything is same. Only for high outlier detection, use plus. For low outlier detection, use minus. That is the difference. Now, as I have already explained, you see, they are also saying if a sample data set is found to have a high outlier, then it must be compared with the peak flow from the historical data and may be adopted as one of the peak flow. If this adjustment is done, then you have to recompute the high outlier again. And in case of low outlier, there also you will get a discharge after you inverse log the low outlier. And if there are in your data set, if there are any data which is less than this data, you have to delete those data as well. For high outlier, if any data is higher than this data, delete. If any data is lower than this data, for low outlier, then delete. Okay, and as I have said, there is a table for critical deviate against sample number of samples you have in your data set. But for the 10% significance, this is given here. This is it. You see, sample size 10, value of K is 2.036. Sample size 60, value of K is 2.83. But you can note that the sample size must be 10 or more. This method is for a longer format of dataset. This is not for a shorter version of dataset. You cannot detect the outlier if your dataset has only 9, 8 or 7 or less than that number of dataset. Your dataset must have 10 or more number of dataset for this type of outlier detection methods to be applied. Right? Now, in the next slide, I will try to give you an example which I will try to solve in front of your eyes, such that you get a real-time feeling of how to calculate or identify the outliers with the help of log Pearson type 3 method. Okay, so as I was discussing about how to detect outliers with the help of log Pearson type 3 method as recommended by the bulletin 17B, right? So let us take an example and I will try to explain the method to you, how to work, how to apply this method to detect the outlier. So suppose this is your data set and you have arranged it from lowest value to the highest value. Okay, so as a first step you have to find the skewness of this data. So that in case of Excel you have ready-made function. Just find the skewness, Q of the entire data set. As I say that if the skew is more than 0.4, you have to first detect the high outlier, that is the largest value outlier. If it is less than minus 0.4, then you have to detect the lowest value outlier first, and if it is plus minus 0.4, then you can detect any of them. So let us see what is a skew. So it is actually, the skew is 0 in this case, because this is a random data set. It is not collected from any real life data. Randomly I have given this data. Now the skew is 0. So that means it is not more than 0.4 or not less than minus 0.4. So it is within plus minus 0.4. So you can actually detect the high outlier or low outlier, anything that you can detect first. So I will detect the both, but first high outlier, then low outlier. Now the next step will be, you have to find the log of each of these values. Okay, so you have to find the log of each of these values. So in case of Excel, there is a log function. Just put log of this. Log A2 means A2 is this value, and log of A2 is given here. It is 1. Log of 10 is 1, because we will use the normalized logarithm. That means log with base 10. Always use that in this case. So log base 10 is 1. So 1 log base 10 11 is this value, and so on. Now we have to find the mean of the log of the sample values. So sample values are these, log of the sample values are these, mean of the log of the sample value is actually the average of this. So I think it is clear to all of you. Now we have to find the standard deviation of the log of the sample values. Now Excel has a built-in function for calculating standard deviation, which is stdev and the series. B2 is to B2 colon B21 is B2. This is B2. B21. This is B21. So that's this entire data set is selected, and I have applied the function stdev. Automatically Excel has calculated the standard deviation of the log of the sample values. Clear? Now if you do not have Excel, you can find the formula of standard deviation from internet or any statistics or mathematics book, and you can calculate. Now, as I have already discussed, the formula for finding the high outlier is this one, right? YL is the high outlier, equals to Y mean, the mean of the log of the sample values, plus Kn. K is the critical deviate, N is the data sample, S is the standard deviation of the log of the data values, which is Y. So these are all given here. Already I have discussed this. This is for high outlier. If high outlier, it is plus. If low outlier, it is minus. All other terms are same, right? So I have calculated the high outlier. Here you see mean is calculated in the cell C2. So C2 plus 2.385 is the critical deviate for a sample of 20 number of data points. 20 number of data points. You see, this is the table, 10% significance value for critical deviate. Sample size in this column, critical deviate value in this column. We have a data set which have a 20 number of data points or data. So 20, you see the K is 2.385. So that is why I have written here 2.385 multiplied by the standard deviation. C4 carries the standard deviation. Here it is C4. Correct? C4, this red box. Okay, so this gives me the high outlier value or high outlier limit, which is equals to 1.605. Similarly, with a minus sign and all other values are same, I have calculated the low outlier limit also. Now you have to find the inverse of this value, because this is in log, this limit is in log. So you have to find the inverse of this log. How to find the inverse of this log? I have said that you will do the logarithm with the base of 10. All the logarithm that you have done on your data is with a base of 10. So when I have to calculate the inverse of that log, just 10 to the power this outlier limit. 10 to the power d2 is the outlier limit. In the d2 the outlier limit is there. So 10 to the power d2, this higher arrow is the to the power in case of Excel. So 10 to the power d2, correct? And similarly 10 to the power e2 will give the lower outlier in value, not in log. Okay, so 10 to the power d2 is the high outlier value, 10 to the power e2 is the low outlier value. Now as I have discussed earlier, you have to now find that whether this outlier value 40.32 is available in your data set or not. Now if I observe this data set that I have taken, there no value is near to 40. So no value is more than 40. If there is any value which is more than 40, I have to delete that. But as there is no value near to 40, the maximum value is 29, so no need to delete anything. Similarly, the low value is 8.572. Anything less than this 8.572, you have to delete it. But there is no value which is less than 8.572 because the data set is started from 10, finished at 29. So lowest value is 10, highest value is 29. So no value is more than 40, no value is less than 8.572. So the data set has no outlier, it will remain as it is. Okay, so if any value was more than 40.323, suppose 41, 42, 43, you have to delete it. If any value was less than 8.572, suppose 7, 6, 5, you have to delete those values. But mind it, for the higher value, if you are finding 40.32 as the higher limit and you have some 42, 43 such type of values, first compare it with the historical values of that data. If you find more value than this 42, 43, 44, they might be one of the extreme events among the entire data set. It may not be the outlier. Okay, it may be a one of the peak event of the data set. So in that case, no need to delete them which are higher to 40. Just keep them as it is. Okay, so this is in short is the way you have to detect outlier with the help of log Pearson type 3 outlier detection method as recommended by the bulletin 17B. Thank you and see you again in the next video.